Hello guys, welcome to today's video. In today's video, we are just going to talk about the terms and conditions that are put on the logarithmic functions. Okay, so the general logarithmic function is defined as log of b to the base a. But here, what I had written that we are taking the log of any positive real number to any base, and if we solve this, we will get exponent as our answer. Means that logarithm means that to what exponent this base must be raised to get this number as your answer, right? So uh, I can represent logarithmic function as y, right? Y equals fx. Okay, means it's a function of x. Okay, and I can write here log of x to the base a. Right? Any general logarithmic function can be defined like this, right? Because this is why it's a function of x, right? So this is your exponent. So it's going to be the function of your positive real number, right? Right? So here x represents your argument or positive real number, right? And a is the base, and this y, it represents here logarithmic function. It represents the exponent power to which this base must be raised. Okay, so generally, uh, if I have to define this logarithmic function in simple terms, I would say that logarithmic function, it's the function that takes the positive, okay, that takes the positive values of the argument and gives us the real values in terms of the exponent, right? Why? Because this number, it has to be positive, so it takes all the positive values, right? And in return, it gives us the real values, right? Okay, so uh, when we define logarithmic function, there are some conditions or certain conditions that are put which says that our base a, right, our base a, it must be greater than 0, and it must not be equal to 1. Okay, now what would happen if we put our base negative or equal to 1? What would happen? Because we just want to know like how things go wrong if we don't follow these conditions. Okay, so let's see. Okay, let's see. So here the general here, just I'm just representing this logarithmic function as y equals fx equals log x to the base a. This is my general equation. Okay, now if I can divide it into the cases. If I take case 1, right, can you see it? Okay, so my case 1 is uh, if a is less than 0, if a is negative. Okay, now if you remember, we have defined all these conditions when we did exponential functions. Okay, but if you do not have any prior knowledge of exponential functions, we can define it here too. Okay, so if a is less than 0, what does it mean? It means the base is negative, right? So what would happen? So then y equals fx is going to be log of uh, minus a to the base x, right? So we have to find log of x to the base minus a, right? A is less than 0. Okay, if now see here I can do one thing if I change the base. Okay, because we haven't studied this thing yet, uh, the changing of base. Okay, but just see here, if I change the base to some other new base, it would be log of b, this new base b, here log of x to the new base b over log of uh, minus a to the base, to the new base b. Now uh, if you look at this, okay, this is your log of x to the base minus a. Okay, if you look at this thing, if you look at this equation, you can see here this is the log of negative number, but log is never defined for the negative numbers. Okay, what does it mean? It means that this thing is not defined, right? This thing is not defined, so that's why this thing is also not defined, and that's why that, and therefore a a should not be a should not be negative. Understand why? Because you cannot find the log of negative numbers. It's not defined. Okay, let's take an example. For example, you have to find log of minus 3 to log of log of log of 9 to the base minus sorry log yes log of 9 to the base minus 3. You have to find this. Now see here, uh, what does it mean? It means that the answer would be to what the answer would be the power to which this 3 must be raised. This 3 must be raised to get 9 as your answer, right? To get 9 as your answer. Okay, now here it's fine because you can put 2 here, so things would be okay. But if, for example, if I have 3 here, okay, then to what power this base should be raised to get 3 as your answer? Now can you define x here? No, it's not defined, right? So that's why your base should not be negative. Okay, for some for some numbers, this can give the right value, but not all the times. There are going to be lots of contradictions, right? For example, for 9, okay, minus 3 square is 9, but what about minus 3 cube? It's going to be minus 9, not plus 9. Okay, so again, contradiction. So that's why it should be less than 0. Okay, let's take case number 2. Let's take the case number 2. I can erase this, right? So case 2 is when case 2 is if your a is equal to, if your a is equal to 1, right? If your a is equal to 1, means the base is 1. The base is 1. Let's see what would happen. So your y equals fx equals log of 1, sorry, log of x to the base 1. Okay, what does it mean? here it means that this is y, right? This is y. It means that to 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 what exponent this one must be raised to get x as your answer, right? Means that equals x. Right now here what would happen if you look at it, so for different values of y, you will get the same value of x, right? Or I can say that for same value of x, you will get multiple values on y, but that's not how function is defined. Function says that it must return a single value, okay? For example, if you draw the graph for this, this is your 0, 1, 2, 3, 4. So it's going to be like this. It's going to be like this. This is 1. So this is going to be the graph of log of x to the base 1. Why? Because for see here, the value of x is mapped to the different values of y. Okay, so it should map to the unique value of y, not not one too many values, right? So that's why the base, it should not be 1. Okay, that's why therefore